Titan and Enceladus, moons that may harbor life. When people think about places in our solar system that might harbor life beyond Earth, Saturn's moons are among the most exciting and mysterious candidates. Saturn, the beautiful ring giant, is orbited by more than 80 known moons, each unique in size, composition, and activity. Among them, two moons, Titan and Enceladus, stand out because they offer the most compelling evidence for environments that could support life. These moons are extraordinary, not only for their unusual physical characteristics but also for the scientific questions they raise about how life could exist in environments vastly different from Earth. The more we study Titan and Enceladus, the more they challenge our ideas of habitability and show us how diverse the solar system really is. Titan is Saturn's largest moon and the second largest moon in the solar system after Ganymede. It is unique among moons because it has a dense, nitrogen-rich atmosphere, which is very rare for a moon. This thick atmosphere creates a hazy orange glow that obscures the surface from view and contains methane and other organic compounds, which are essential building blocks for life. The presence of these organic molecules makes Titan a fascinating natural laboratory for studying prebiotic chemistry and the processes that might lead to the emergence of life. Titan's atmosphere also creates weather systems, including methane clouds, rain, and even seasonal changes, giving the moon a climate and hydrological cycle comparable to that of Earth, but with entirely different materials. Exploration of Titan began in the 1980s and 1990s with observations from the Voyager spacecraft. These missions revealed a thick, hazy atmosphere and hints of surface features, but much of the detail remained hidden. It was not until the Cassini-Huygens mission, a collaboration between NASA and the European Space Agency, that scientists could explore Titan up close. The Huygens probe, which landed on Titan in 2005, provided images of river channels, lakes, and vast plains, while Cassini mapped the surface and atmosphere over several years. One of the most astonishing discoveries was that Titan has lakes, rivers, and seas, not of water, which is frozen solid at Titan's frigid temperatures, but of liquid methane and ethane. These hydrocarbons flow through valleys and collect in large basins, forming seas hundreds of kilometers across. Titan also has sand dunes made of organic particles that cover extensive regions, shaped by winds in a manner similar to Earth's deserts. The combination of liquid hydrocarbons, organic chemistry, and dynamic weather makes Titan one of the most Earth-like yet alien worlds in the solar system. Scientists speculate that if life exists on Titan, it would be radically different from life on Earth, potentially using methane or ethane as a solvent instead of water. Enceladus, by contrast, is a much smaller moon, but it is no less remarkable. It is covered in a smooth layer of ice, making it one of the brightest objects in the solar system because it reflects nearly all sunlight that strikes it. Despite its small size, Enceladus has drawn intense scientific interest because it harbors a subsurface ocean beneath its icy crust. Evidence for this hidden ocean comes from geysers of water vapor and ice particles erupting from fissures near the moon's south pole, often referred to as tiger stripes. These plumes rise hundreds of kilometers above the surface, carrying water, salts, and organic compounds into space. Analysis of the plumes by Cassini revealed that Enceladus has the essential ingredients for life: liquid water, chemical nutrients, and energy. The discovery that Enceladus has a subsurface ocean and active hydrothermal processes on its ocean floor makes it one of the most promising places to search for life beyond Earth. The heat that sustains Enceladus ocean comes from tidal heating. Gravitational interactions with Saturn and neighboring moons cause friction inside Enceladus, keeping its interior warm and driving hydrothermal activity. On Earth, hydrothermal vents support diverse ecosystems without sunlight, relying entirely on chemical energy. scientists believe that similar vents could exist on Enceladus' ocean floor, providing a habitat where microbial life could thrive. What makes Enceladus especially exciting is that the plumes provide a way to study its ocean remotely, as material from the subsurface is ejected directly into space. This allows spacecraft to sample Enceladus' ocean without the need to drill through kilometers of ice, offering a unique opportunity to search for signs of life beyond our planet. Titan and Enceladus together illustrate the incredible diversity of potentially habitable environments in the outer solar system. Titan, with its thick atmosphere, methane lakes, and rich organic chemistry, represents a world where life could exist in forms entirely unlike anything on Earth. Enceladus, with its icy crust, hidden ocean, and active geysers, presents a more familiar scenario, where water, nutrients, and energy come together to create a potentially habitable environment. Studying these moons not only helps scientists search for extraterrestrial life but also teaches us about the processes that shape planetary bodies, the dynamics of icy worlds, and the limits of habitability. The exploration of these moons is far from over. NASA's Dragonfly mission, set to launch to Titan, will study its atmosphere, surface chemistry, and prebiotic conditions in unprecedented detail. Future missions to Enceladus are being planned to fly through its plumes, collect samples, and possibly even return them to Earth for laboratory analysis. These missions have the potential to answer some of the most profound questions in science. Is there life beyond Earth? And if so, what forms does it take? Titan and Enceladus remind us that the search for life is not limited to planets like Earth. Even small moons, orbiting distant gas giants, may hold the key to understanding our place in the universe. In simple terms, Titan and Enceladus are far more than icy moons circling Saturn. Titan is a world with a thick, nitrogen-rich atmosphere, flowing methane seas, and complex organic chemistry that could support exotic forms of life. Enceladus is a small moon with a hidden ocean, erupting geysers, and the potential for hydrothermal activity similar to Earth's deep ocean vents. Together, these moons challenge our understanding of where life could exist and inspire the ongoing search for habitability beyond Earth. By studying them, scientists are discovering that life may not require conditions like those on our planet and that the universe is far more diverse and mysterious than we ever imagined. If you enjoyed learning about Titan and Enceladus and the incredible possibilities that these moons offer for life beyond Earth, do not forget to like the video, share it with your friends, and subscribe to the channel for more engaging, easy-to-understand content about space, science, and the wonders of the universe.